Hi, Roger McGould is here with Diana Shaw, who works for SAS. Welcome.
Thank you.
So SAS has this long history in statistics and this kind of advanced mathematics. What is your approach to AI?
Well, at SAS, we define AI as the science of training systems to emulate human tasks through learning and automation. So for us, we're really actually creating a lot of AI within our applications themselves, the software. So we're adding a lot of automation and intelligence to make it easier for people to get through the full analytic lifecycle. That really helps us because then we can create AI applications in a very wide range of topics. Whether they're using text analytics or computer vision, we can get through the entire application very quickly. There's a lot of automation and intelligence to help us along the way.
Great. So can you share some examples of how customers are actually putting this in practice?
Yeah, we're really excited. There's some really great work that's going on at the Amsterdam University Medical Center, where they're using our computer vision capabilities to actually emulate how a radiologist would look at CT scans to determine how patients are progressing after they've gone through chemotherapy. And in fact, they've actually automated the full calculation to determine whether or not the chemotherapy is working well. And from that, they're able to make decisions as to whether or not they have to go in for surgical removal or other paths on their chemotherapy or their cancer journey.
So I'm curious, with an application like that, and health is such a fraught issue in some ways, how does the kind of human and AI interface work?
Yeah, well, so you really want to have humans being able to use their brain for what humans do well, which is thinking, empathy, creative insights. Whereas machines are incredible at being able to deal with a lot of data and really complex algorithms and be able to deal with all of that at scale. So it enables us to really take some of the tedious work, the stuff that you've done, maybe you've done a report once or twice and you think to yourself, why does it take so long to create it? Have the computer do that, automate that process, and then free up the time so that you can be more creative and you can think through how to solve other problems and derive insights and have more data-driven decisions. So that's how we approach it.
Mm-hmm. Great. And where do you see AI moving next year and maybe even looking out a few years?
Yeah, I really think AI is going to move out of the lab and more into the general space where people are going to be dealing with it. And the reason why I say that is there is a lot being done in terms of automating a lot of the steps that a data scientist would go through in order to create an AI application. So being able to free them up to be able to accelerate their journey. In addition to that, there's actually a lot of democratization that's happening for AI to be able to empower people that may not have gone and done their master's or PhD in computer science or analytics or anything regarding AI. But we're now enabling others to be able to have the power of advanced analytics to be able to add and create more as part of a team sport. And then with technology that's allowing us to easily embed and deploy those models very quickly into a productionalized environment is really where I think we're going to take AI out of the lab and really move it into the commonplace applications.
So on that journey, there must be some challenges. And you guys sit at one end of the kind of the model building and analytics side. Data is obviously a big space. Where do you see the challenges?
There's a couple challenges. So there's challenges in the sense of data itself. A perfect case in point is we at SAS actually wanted to use our own images to be able to use computer vision when we walk into a building so that the receptionist would be able to quickly know without having to wait for us to flash our badge for whether we were allowed access. And one would think that we're working for a company that would enable this, but because we never actually opted in from a legal standpoint for our images to be used in that regard, we can't use it. So I think data is still a little bit of a challenge, especially for computer vision applications like that. But then also in terms of ethics and in terms of explainability, I think those are some other challenges. At SAS, we're doing a lot in terms of generating explainability in terms of a natural language output so that a data scientist or a citizen data scientist can really understand what that mathematical algorithm is doing so as to make sure that it's really solving the problem that it was intended to solve. But then when we think about the ethics situation or we think about maybe bias as well within the data, this is where having data science be more of a team sport where you can have, the trained, really classically trained and strong, capable data scientists work with the citizen data scientists, work with the business practitioners, work with, medical stewards and things like that. Having everybody work together, we can make sure that we really understand whether or not we have biased data going in or if we're making biased decision making, so that we can make sure that that application in the end is as bias-free as possible, very, very explainable, and then something that can be utilized by the masses. Because if we create something that's really complex, what we find is that the business community doesn't actually want to use it if they don't understand it. So we need to have them being bought in and be part of that team initially, early on.
Hey, that actually jives quite well with what we have been finding ourselves.
Oh, good.
So thank you for your time.
Thank you.